Inverse proportion. Two quantities may change in such a manner that if one quantity increases, the other quantity decreases, and vice versa. For example, as the number of workers increases, time taken to finish the job decreases. Similarly, if we increase the speed, the time taken to cover a given distance decreases. Let us consider an example. Zahida can go to her school in four different ways. She can walk, run, cycle, or go by car. Study the following table. Walking speed is 3 km per hour, running speed is 6 km per hour, cycling speed is 9 km per hour, car speed is 45 km per hour. So here speed is increasing. Now if she goes to school on her own, then by walking, then it takes 30 minutes. Then running, the time decreases because the speed increases. By cycling, the speed becomes 3 times, so the time reduces by 1/3. Similarly, by car, the time required decreases. So as speed increases, time required decreases. So such a relation is called as inverse relation or inverse proportion. One more example. Let us consider another example. A school wants to spend rupees 6,000. The amount to spend on books is fixed, that is rupees 6,000. On mathematics textbooks, how many books could be bought at rupees 40 each? Clearly, 150 books can be bought. If the price of textbook is more than 40, then the number of book which could be purchased with the same amount of money would be less than 150. Now if total amount is 6,000 and cost of each book is 40, then the number of books purchased will be 150. Now if the cost of book increases, number of books decreases. For 60 rupees cost, the number of books can be purchased is 100. So as number of books increases, as cost of book increases, number of books purchased in rupees 6,000 decreases. Now let us observe these numbers. If we consider this as x and this as y, let us find out x into y for each pair of cost of book and number of books. This is 6,000. 15 4s are 60, so 6,000. 12 5s are 60, so this is also 6,000. 100 into 60 is 6,000. 75 into 80 is also 6,000. 80 into 75, 6,000. 100 into 60 is 6,000. So here we observe that in inverse variation, the product x into y remains constant. If we represent the price of one book by x and number of books bought as y, then x increases, y decreases, and vice versa. It is important to note that the product xy remains constant. We say x varies inversely with y and y varies inversely with x. Thus two quantities x and y are said to vary in inverse proportion if there exists a relation of the type x into y is equal to k. K is constant and x into y means the product of those numbers. So if this product is constant for all the pairs of numbers x and y, then we say that x and y are in inverse proportion. One more example. Take a squared paper and arrange 48 counters on it in different number of rows as shown below. Here the number of rows is 4. Then to accommodate all these 48 counters, there must be 12 columns or 12 counters in each row. But here if we increase the number of rows increases 6. From 4 it becomes 6. So number of column decreases. So this is the case of inverse variation. Now we have to identify are x and y vary inversely. This product is 250, this product is 240. As these are not equal, this is not example of inverse variation. Here this product is 6000, this is also 6000, this is also 6000. So this x and y in this table are in inverse proportion. Here this is 900, 900, 900, but this one is 750. So x and y in table 3 do not vary inversely. Here are some examples. 6 pipes are required to fill a tank in 1 hour and 20 minutes. How long will it take if only 5 pipes of the same type are used? Now we are a decreasing number of pipes, so the time required to fill a tank will increase. Let the desired time to fill the tank be x. Thus we have following table: number of pipes 6, then 1 hour means 60 minutes plus this 20 extra minutes, so this becomes 80 minutes. How long will it take to if only 5 pipes are used? Number of pipe is decreasing, so time required will increase. So this is case of inverse proportion. In inverse proportion, x into y is constant, so 6 into 80 is equal to 5 into x. Therefore, we can obtain value of x by finding 80 into 6 upon 5, that is equal to 96. So with 5 pipes, it can be filled in 90 minutes, that is 1 hour and 36 minutes. There are 100 students in a hostel. Food provision for them is for 20 days. How long will it be? Will these provisions last if 25 more students join the group? Food provision for 20 days if the number of students is 100. How long will this provision last if 25 more students? Now the number of students is 125. As the number of students increase, the days for which the provision will last will decrease. Note that more the number of students, the sooner will the provision exhaust. Therefore, this is the case of inverse variation. So, product is constant, that is 100 into 20, which is exactly same as 120 into 5. So, by solving this, we can get value of y. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Now the time required decreases. Therefore, to build the wall in lesser time, we have to increase number of workers. So we write this in column form: number of hours and number of workers. As the time decreases, number of workers must be more than 15, that is it decreases. So it is example of inverse variation. So product is constant. So similarly we can solve the questions in exercise 11.2.